Hello, geometry. Welcome to another week. This week is only 4 days long. It's going to be pretty nice for you guys having Friday off. We teachers will still be working. We're doing some professional development on Friday, so know that we miss you. And if you do send us any emails on Friday, we might not get to it until later that day. But hopefully you guys are taking Friday as a day off and having a chance to relax and restore a little bit. This week, we're going to be looking at how do you perform multi-step transformations. And so that's just a fancy way of saying, how do you do transformations on one shape multiple times? And so as a quick review to the answer, how do you do multi-step transformations? We first need to do a quick little overview as to what are those transformations. And they are rotations, reflections, and translations. So, ladies and gentlemen, if any of these three you feel uncertain or have questions about, then please immediately make it your priority to go back to that module and practice it, rework it, email me questions, because in order for this week to make sense, you're going to need to do all of those three, primarily reflections and translations. So in this unit, we will cover rotations, but primarily reflections and translations. The reason why is because there is a particular named multi-step transformation that has some prominence, and that is something called a glide reflection. So, ladies and gentlemen, we will define and show some examples of this here in a moment. But first, I want to go ahead and debrief these three one last time, in particular about the notations that these three had. So this particular curriculum has three different notations that they emphasize and use that aren't the most common that you see in the world, but you do see them occasionally. Otherwise, the curriculum wouldn't use them, right? And so for rotations, the notation that this curriculum uses that you'll see in some of the questions on the quiz and practice is they use a little r, and then as a subscript in parentheses, they'll tell you the degree of rotation and then about where it's at. Now remember that language, we rotate about a point, we rotate around a point. And so they'll give you the point that you're rotating around, but they won't give it as a set of coordinates, they'll give it as a name. And so when it's the origin, they'll write an O. So that's an O for origin. Just as an example, could be A or B or C, but they'll have it as a subscript, parenthesis, 90 degrees about the origin. And this is a positive 90 versus a negative 90. Now, when we talk about reflections, they'll use a capital R, and then in the subscript, they'll tell you the line that you're reflecting around. In this case, I'm going to write the x-axis there. That's not how you spell axis. Versus the y-axis. And for translations, they'll put a giant T, and then in the subscript, they'll have the pointy bracket because pointy bracket represents the translation, and they'll give you the numbers for the translation. I'm just going to write 5, 3. And remember, that means 5 to the right and then 3 up, because that's the x and y, negative versus positive. One last note, if it's a positive rotation, always assume that's counterclockwise. Positive is counterclockwise. Now, ladies and gentlemen, there's one last piece that I want to be able to illustrate before we really dive deep into glide reflections and multiple transformations. And ladies and gentlemen, that is our notation for our image. So image just means the shape after our transformation, and the notation we use for that is we give our point a prime, right? And so that's going to be our first image versus an A double prime, which is our second image. Ladies and gentlemen, if I haven't said this enough, then this might sound as a surprise to you. But one of the things that I commonly say, and you would have heard me say repeatedly by this time in the year if we were in person, is that math is a language. And so here's an example where that linguistic style comes in. Some mathematicians will just use A prime for multiple transformations, considering the multiple transformations happening on a shape as the pre-image and then the one image at the end. And that's a stylistic choice. They don't really count the middle steps in between. While other mathematicians are very intentional, and they will give each shape in the middle a new name with primes on it as you work through. So some of the practice problems will have one, some of them will have two. Don't get caught up on it. Don't get hung up on it. That completely is just about the linguistic style. And so if it has one prime, it's not just talking about one of the parts of the multiple transformations. It is referring to the very end still, and just counting the multiple transformations as just one block from the image and the pre-image. So, ladies and gentlemen, with that clarifying points out of the way, let's talk about a glide reflection. And a glide reflection, remember, composition just means putting transformations together. So a glide reflection is the composition of a reflection and translation. So if you reflect something and then translate it, that is a glide reflection. So let's go and take a look at an example of that. Let's go ahead and give ourselves a fantastic X and Y axis here. And let's go ahead and give ourselves a triangle. What's your favorite triangle right now? Let's go ahead and make it a right triangle, because we always like it when things are correct. So there's a right triangle right here. I'll name it A. No thank you, sticky keys. B and C. So, ladies and gentlemen, for this glide reflection, I'm going to do the composition of a reflection, and I'll use the notation, a reflection over the y-axis. And yes, the y-axis is the subscript, and it is an entire word as the subscript to the big R. The subscript is just a name. It's just a label. So putting a whole word there, not a problem. Composed with, and remember we draw a little O to mean composed with, the translation, big T with a pointy bracket, -4, 5, and the pointy bracket. Now, because I'm showing this step by step, I will use the prime to represent the reflected image and then the double prime to represent the translated image, because I want to be extra clear and I want to be intentional about my middle steps. A different mathematician would just show the work, have the end, and put a single prime on there, and they wouldn't really think much of it. I'm going to go ahead and do this rotation, or sorry, not rotation. I'm going to do the reflection in green here. Green's a great color. So let's reflect over the y-axis. The y-axis is the vertical line down the center. And remember, By doing this by hand, we want to find that perpendicular distance from our line of reflection and then just find the equidistant point on the other side. So C is 2 spots away, so C prime's 2 spots on the other side. Boom, C prime. Same thing with B. B is 4 spots away, and so 4 spots away on the other side. 1, 2, 3, 4. Here is B prime. Last but not least is A, 4 spots away, so 4 spots away on the other side. Here we go for A prime. Here is our reflected triangle. Brilliant, love it. 10 points for Gryffindor. Now we want to translate 4 units to the left and 5 units up. Now, if I was more intentional, I would have realized that I didn't have enough room. So actually what I'm going to do, I'm going to just, pretend like I put that negative on the 5 this whole time. That way my problem actually ends up in a cleaner spot to be able to follow our work on. Ladies and gentlemen, so now I'm going 4 units to the right and 5 units down. It was that way the entire time. Drink some coffee. I know you'll believe me. So for this shape then, I'm translating it 4 units to the right, 5 units down, but not the original, the image here, because we're doing multiple translations, we're doing multiple transformations at once. And so in purple, we're going to go ahead and do that translation. So we're going to be translating all of our points by the vector. That is 4 units to the right, 1, 2, 3, 4, and 5 units down, 1, 2, 3, 4, 5. So C prime is going right here to get C double prime. And then I'm doing the same thing for all of our other points. B double prime ends up right here on the axis, because if I go 4 units over and 5 units down, it lines up perfectly. And then same thing with A, it also ends up on the axis. 4 units over, then 1, 2, 3, 4, 5 units down. A double prime actually ends up right here at the origin, which is pretty convenient. So our final shape after both of our reflection and translation is in purple. That is the glide reflection from the pre-image, our black shape, to the image, our purple shape. Let's go ahead and show another glide reflection example here. There it goes. This time I'm just going to do a glide reflection of a single point. Let's put it on right here. Let's pick this spot. This is the point 1, 2, 3, 4, 5, -5, +2. So, ladies and gentlemen, and let's do this glide reflection as the composition of the reflection over the x-axis composed with the translation of the vector +7, -3. So first, reflect over the x-axis. Let's go ahead and make this particular image in blue, because who doesn't love a good color blue, right? So here's our x-axis. For this single point, we just want to find that perpendicular distance away. In this case, that's a distance of 2. So 2 down, right there, is our image. I forgot to give this point a name. Oh, what do we want to call this point? I mean, I could be boring and call it P for point, or we could be cool and like call it a W or something. Let's call it a W. W is a great, you know what? Even better, let's call it K. Nailed it. And so our new point is K prime. Now we want to translate that 7 to the right and down 3. And so we're going to go ahead and take this and go 1, 2, 3, 4, 5, 6, 7 to the right and down 3. And so that's going to be our vector. Remember, vectors are represented by arrows. And I'm going to go ahead and draw this new point in red for that transformation there. And here is our final point, K double prime. So ladies and gentlemen, I'm going to go ahead and just for show erase our middle step. Because this point up here, K, is the pre-image. This point down here in red, K double prime, is the image of the glide reflection. So this is the composition of our transformations, the reflection and the translation that gets us from here to here. And then, of course, you can put down the middle to help show your work. Ladies and gentlemen, I'm going to show you guys one more example. It's going to be of a rotation and then a reflection. Ladies and gentlemen, even though I'm not doing an exhaustive list of every type of example of all the possibilities of translations, reflections, and rotations, if you know how to do each of these three in isolation, then you are incredibly prepared to do this week's lesson because you are just doing each of these three in order. And so that's what happened here. I did a reflection first. That is what we covered from that week we did reflections. And then I did a translation second. And so if you can do a reflection and you can do a translation, then you can do the composition of just doing them in order. And so that's where I keep coming back to. If you feel like any of those three you feel stuck or have questions on or didn't really feel confident in the week of, please go back and review that unit, or that week, I should say, and send me an email. I'll do my best to explain it a different way, meet with you in one-on-one, and help it make sense. And so this last example, let's go ahead and pick our color black here. We're looking at a rotation and then a reflection, and this doesn't have a special name. The only combination of composition of transformations is the glide reflection, and that's a reflection and a translation. None of the others have a special name. It is just a composition of two transformations. And so we are going to rotate and so this rotation is going to be 270 degrees, and remember it's positive, so it's counterclockwise, about the origin. That's what the O represents. It's not a 0, it's an O for origin. And we're composing that with the reflection over the y-axis. And I'm just going to model this with a point. And so let's go ahead and draw ourselves our graph here. Oh, that wasn't straight. There we go. There we go. And, what point do we want to pick? Let's pick this one. And let's call this one B. B's a great point. And B happens to be at 4, 3. So, ladies and gentlemen, first, counterclockwise 270 degrees, which means we're rotating all the way around the graph. Boom, 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 270 degrees. So let's go ahead and break that down. 4 and 3. 4 was going to the right and 3 was going up. So rotating the right 270 degrees. A student showed me this just a couple days ago, actually, and I want to share it with you guys about rotations because I found it to be incredibly insightful. What they did is they drew a set of arrows like you would a pair of axes, but this helped them identify which direction you were going after a certain degree measure, because each arrow is 90 degrees apart from the other. So 4 is going to the right. Well, then you're just counting 270 degrees from there. So you're counting. I'm sorry, I just noticed that I've been saying right and I drew it to the left. I'm such a doofus. Okay, there you go. Fixed it. You can tell I haven't had coffee within the last 10 minutes to be able to do this problem correctly. But now we got it. So 4, going to the right here, means that we're able to count this from the right and go 270 degrees. So 1, 2, 3. So what was going to the right after our 270 degree rotation means we are now going down. And then for the 3, which is going up, we're able to count that 270 degrees from up. So go ahead and count that 270 degrees from up. 1, 2, 3. We are now going left. And so what was going up is now going 1, 2. Right. Right. What was going up is now going to the right. And so when we go to plot down our point after our rotation, from B, we're able to get to B prime, which is 3 to the right and 4 down. Now, all that's left is reflecting it over the y-axis. And I'm going to go ahead and do this part in blue. So our reflection over our y-axis, like I talked about before, is finding that perpendicular distance. In this case, we are 3 away. So 3 on the other side gives us the point we're looking for B double prime. And where's this point at? Well, it happens to be, this time I finally got it, 3 to the left and 4 down. And so, ladies and gentlemen, here we are. We did our composition of transformations, the rotation 270 degrees around, and then the reflection to get to our final point. Ladies and gentlemen, good luck. I have full confidence in your abilities, and don't hesitate to email me any questions or concerns you have, and I'll be glad to help. Take care.